Hello and welcome to 5 Reasons DevOps Toolchain Needs Time Series-Based Monitoring. I'm your host, Mike Bizard, and we're going to get started in about 1 minute. All right, everybody, welcome once again to 5 Reasons DevOps Toolchain Needs Time Series-Based Monitoring. Our presenter today is Nadeep Sidhu, Head of Product Marketing for InfluxData. He's going to give us the who, what, when, where, and why of monitoring. Nadeep, take it from here.
All right, thanks, Mike. Welcome, everybody. Good morning, good afternoon, good evening, depending upon which time zone you are joining. We have several hundred people signed up to attend today's webinar. So thank you all for joining. And for those who are not able to join or joining a little bit late, this will be recorded and you will have the access to recording. So with that, let's get started. And the topic today is the 5 reasons DevOps toolchain needs time series based monitoring. And we will try to cover several pieces here. So if you're not familiar with time series and what time series based monitoring is, we will try to make sure by end of this webinar, you understand what time series is and how it can help with your DevOps toolchain monitoring needs. The goal here is to wrap up the webinar in 40 to 45 minutes so that we have some time for Q&A at the end. And if you have any questions, please hold off until we start the Q&A. So why is DevOps important today, and who does it concern? And should you only be concerned if you're building new apps? So based on the research that we have done in the market, we see a lot of legacy apps that are being replaced for several reasons. Primarily usability, scalability, responsiveness, and also mobile and IoT needs, just because the legacy apps do not work very well with mobile and IoT. And then we also see urgency in developing new customer-facing apps. And almost every application, except for perhaps some back office apps for finance and accounting, other than those apps, everything else is being modernized, especially the customer-facing apps. So there are many ways you can go about modernizing these apps. You can either find a low-code platform, start building your own apps on top of this platform, or you can figure out the pieces of technology yourself and start building, say, a microservices architecture, and then start building apps on top of that architecture using a number of microservices. And it also depends on what kind of app you're building. Your app could be a process-driven app, for example, a mortgage approval app, which goes through a series of steps, or an IoT-driven app where it is getting data from sensors and exchanging information with sensors and devices. But no matter what kind of application you build, there is one thing that you will need, as all modern architectures have this thing in common. And that need is that they need better monitoring. Now, obviously, the question is, why better monitoring, right? So if as a developer, I go to my manager and say, hey, we need better monitoring for the new application infrastructure, the question will be obvious. Why better monitoring? And these are the 5 reasons. We talk about these 5 things when we talk about modern application architecture and the need for better monitoring. So always think about why you are building these apps in the first place, right? They have a better UI, they look and feel better, they provide customer satisfaction, perfect. But these are the 5 fundamental things that basically drive an organization to build better apps. So when you start monitoring modern applications built using modern application paradigms such as microservices, low code, process driven apps, and suddenly the old monitoring tools are not enough. So let's start from the top. Why? So high uptime is something that is at the core of the architecture. When you're driving the modern application architecture, you're building modern apps, you want them to be up all the time. And this high uptime actually requires sub-second visibility into the architecture because 99.9% the chances are that you are deploying it on a cloud infrastructure. And one of the biggest benefits of cloud is you need to figure out what is working, what's not working, do you need to scale, how do you troubleshoot. So all that requires sub-second visibility. And remember, the architecture has changed. If you look at the legacy systems, in a three-tier architecture, there used to be an app server, a database engine, and a hardware network, some routers and some boxes. An application server was simple. It could run multiple applications, and as long as the hardware and network had no issues, all you needed to worry was the app server and the database performance. So there were only a few things that you needed to monitor. Now, as the application and architectures have shifted from monolithic to microservices style architectures, different styles of modern application architectures have one thing in common. They spit out more metrics than ever before, and both the volume and the frequency is very high. So these are, these 5 reasons we talk about. These are the reasons why existing monitoring solutions, or as we call them, legacy monitoring tools, don't work. The complexity, the ecosystem of microservices, it is so complex because one microservice could be dependent upon one, two, or even dozen services and APIs under the covers, and it could require cross-domain visibility. So one department, one IT team could be working on one microservice, but they might be dependent upon other services published by other IT teams. So in reality, if you're trying to measure the performance of that microservice, you need to figure out what is causing the microservice to perform slowly compared to its performance yesterday. Is that something going on in our system, or is that something going on in the IT team, which is powering some of the dependent services, right? So you need visibility across domains within IT. And the third point here is scaling. I alluded to scaling a little bit, but a big premise of our going adoption of cloud is the ability to auto scale, right? So cloud gives you infinite scalability, and take that with a pinch of salt. You can only scale as far as your cloud provider's data center allows you to scale. But even then, assuming that your scaling needs are not that large, that go beyond a data center, if you need to scale, you need to have sub-second visibility into how your architecture is performing today. We were talking to a customer, and they wanted to be able to trigger their auto scaling in 15 seconds. So they wanted to determine if their e-commerce platform is not behaving right, and it is the number of visitors, customers, and prospects to their website was so high that they wanted to trigger everything. They wanted to detect it at a sub-second level and trigger the auto scaling so that a new virtual machine is ready to take some of the load off within 15 seconds. And the best their existing systems could do was 15 minutes to an hour. And they did not have sub-second visibility into the memory, the response time, the HTTP parameters, the network monitoring. And as a result, the best thing they could do was 15 seconds, which was not acceptable to the business. And the next point is volume. The legacy systems cannot handle volume of metrics generated. And we need to talk about this point a little bit because the legacy architectures did not generate that many metrics. As I mentioned earlier, you had application server, database server, and maybe some hardware that these servers are running on. and some routers. So if you look at these 3 or 4 tier architectures, you only had 50 to maybe 500 metrics to be concerned about and to measure to make sure that your application is working fine within specified parameters. Not anymore. Now you have an app server which is virtualized in a Docker container and it is running in some, maybe cluster somewhere, and you are using Kubernetes to orchestrate things. And there are just simply so many layers of architecture today. And when you combine that with the DevOps tool chain, there are dozens of pieces in this puzzle, and the volume of metrics generated by each layer within this architecture, each container, each virtualization layer, it is huge. We have customers who are consuming millions of metrics and events per second. And then the last point is instrumentation. DevOps requires, the DevOps tool chain requires that multiple products, multiple components, Chef, Puppet, etc., they all work together in tandem to deploy your application. And the only way you can instrument all this DevOps tool chain is by measuring the metrics and operationalizing this tool chain to make sure that all this deployment and after the deployment, the uptime is meeting the requirements of the business, right? So 5 points here why you need better monitoring. And let's talk about, we talked about legacy and what legacy cannot do. Legacy monitoring fails at those 5 things. Now let's talk about emergence of time series platforms for advanced monitoring. The first point here is, the workloads for metrics and events have changed. We have an explosion of connected things, and this is not a real-time explosion. This is a huge growth in the connected devices and things, as we call them. And this explosion in the number of these connected things is now impacting your application architecture as well. Now, you might have an application which is getting data from sensors into the application, showing it in a graph format, or showing the usage of electricity, water, or some power consumption, or the status of your battery getting charged on the app itself. So when you are getting data from millions of devices, or if not millions, then hundreds of thousands or tens of thousands, your traditional application architecture cannot handle it, and your monitoring system simply cannot handle this millions of devices connected onto and providing data for your app. The second point is instrumentation of the virtual world. So my favorite example is you go to a manager and say, hey, we need better monitoring solution, and the manager says, why, right? We had servers in the past, so what has changed? What has changed here is that you had the server in the past, and when you deployed an application onto your app server, and let's say the application was slow, just because over time you had deployed 5 or 10 applications onto that app server. Guess what? You couldn't do anything. You basically took that performance numbers and started a bigger box, or went to the procurement to buy a new box, and IT said, hey, getting a new box is the lead time is 3 months, and you couldn't do much. So you might have had some information, but you couldn't do much with that. And with instrumentation of the virtual world, now you can take that information and you can do something with this, whether it is a sensor, piece of sensor which is giving you information, or it is maybe it is the virtual machine that is telling you that you're running out of memory or disk space, and you can instrument, you can extend your memory, you can create another virtual machine, you can do something with that data. So having visibility has become more important, because now you can actually use that data to do auto scaling, you can provision a new virtual machine, and you can do troubleshooting faster. So this instrumentation has many different connotations, and now you can do a lot of that instrumentation with the new metrics and events platforms that we will be talking in the next few minutes. And finally, consolidation of metrics and events data. So you have tons of metrics and events coming at you from servers, virtual machines, whatnot, Kubernetes. So how do you consolidate and make sense out of all of these metrics and events? And this is a big issue today, and this is where time series data platforms, they come in and they fix the problem for you. So we talked about metrics and events, and before we go and talk about the time series platforms, let's understand what metrics and events are. What are the different attributes for metrics and events? How are they different? And what are the common things between metrics and events? So they're both timestamp data. Metrics and events, you can use them in the similar connotation. They're all timestamp data. Metrics are generated in a regular fashion, and events are generated in an irregular fashion. So let me give you an example there. So your CPU at a given time is generating multiple stats: cycle time, open threads, temperature, and it doesn't need you to do anything. It is going to spit those pieces of information out. And in some operating systems like Windows, you can go to Task Manager, you can check your CPU cycle time and memory status and caching status and all that stuff. And that is just for you to understand how the system is behaving. So all these metrics are generated every second, every millisecond, but there's a regular pattern to that. On the flip side, the events are similar, but as they are also time-stamped, but there is no unique pattern. Event could be a user trigger event or a system event. Let's say there's a page fault in the memory management, and that is an event. You have to track how many page faults you have, but you can't predict that the page fault will happen every 5 milliseconds. Similarly, it could be a user-triggered event where a user goes and logs into a website and then browses a few products and adds a few products to the cart, then adds a few more, deletes some, and then finally checks out. So everything could be browsing a product, logging in, checking out, making a payment. All this could be a user-defined event as well. And the third point here is huge volumes of data. More than events, metrics today are increasing the data volumes so much that any legacy monitoring platform today cannot handle the metrics and events which are being spit out by the modern DevOps architectures. All right, so what makes time series different? And why do you need a different platform? So the requirements have changed. The new DevOps tool chains, DevOps architectures, the microservices architectures, they are spitting out so many metrics and events that ingestion of such large volumes of metrics and events per second by your legacy monitoring is just not possible. And legacy monitoring has different levels. There are tools that were built 20 years ago, and then there are tools that were built in the last 10 years. And some of these sample data at 5-second intervals. Some of these, the better ones, can sample data at a 1-second interval. But majority of these tools cannot go to a millisecond or a nanosecond level. And as you go to the nanosecond level, you will find that the problem becomes even larger because now you are ingesting large volumes of data every nanosecond, right? So where do you find a platform which can ingest millions of metrics per second? And the second point is real-time queries. So when you get a lot of these data sets, the point is to get visibility. So you need to run queries on these large data sets. And when you run queries on these large data sets, the query volume, the concurrent query volume becomes so high that traditional systems simply cannot support it. And then the third point is about eviction and transformation of data. So let's say you have tens of thousands of sensors sending you data, and you analyze the data, you downsample it, you store it, but then you don't really need the data from yesterday. And how do you evict that data? And how do you compress some of that data? How do you downsample high precision data, right? And finally, the final point is about storage optimization and compression. A lot of cloud vendors will charge you based on how much you store. And if you optimize your storage, then it is in your interest. So you want data, you want to analyze data quickly, you want to absorb all the data without missing any critical data. You want to downsample it, you want to store it, and you also want to delete the data you don't need, right? And I'm talking about terabytes of data here. When you have terabytes of time series data, how do you get to a point where suddenly your legacy platform fails, and what are the options? What are the options when it comes to supporting all these requirements on this slide here? So based on all this emerging needs of the time series metrics and events, we think a new architectural approach is required because time series data is not similar to anything that you have seen in the past. It is timestamp data, as I mentioned earlier. It is not relational at all. It is not search data. You don't need to, you don't have logs and web pages. And it is not a big data type of data. It doesn't have that multimedia files and those JSON objects you're searching through. So we think you need a new paradigm. You need time series platforms for metrics and events. And at InfluxData, we are singularly focused on delivering a time series platform. And I think this is a time where we take a detour and learn a little bit more about the time series platforms. So this is our complete tech stack for advanced monitoring. And this spans all the four components. TIC stands for T for telegraph, I for InfluxDB in the middle, C for chronograph on the top, and K for capacitor at the bottom. So all these four components of the stack, they provide a very well-defined function. And when they work together, they lay the foundation of advanced monitoring capabilities for DevOps and microservices style architectures. So let's begin with Telegraph. Telegraph is an agent for collecting and reporting metrics and events. And it has over 200 configurations for collecting data from systems, databases, network devices, message queues, and different applications. So we call them plugins. So we have around 200 plugins. So the way it works is you install Telegraph, for example, on a Linux box. And all you need to monitor on that Linux box is some system parameters for memory, CPU usage, and those kind of things. And you just go into the Telegraph configuration, the conf file, and you enable the plugins that you need to be monitored. And it will not report anything else, but it will report only the parameters that you want to be enabled. And similarly, you can install Telegraph on any other database or message queue, and it will start listening to what you want to be reported. So Telegraph agent for collecting metrics and events. And as those metrics and events happen, Telegraph reads them, creates those data points sends the data over to InfluxDB, which is the purpose-built time series database. We have built this database from ground up to handle time series data. And this database is specifically for time series only. You cannot store relational or other types of objects. It's all about time series. And what happens is, as the Telegraph is sending those data, let's say you have hundreds of servers, you have, your DevOps toolchain emitting data, your virtual machine, your VMware, your Docker, your MySQL, all these components have Telegraph running on them, and they're all sending metrics for reporting and collection. All those metrics go into InfluxDB, and InfluxDB is able to ingest all those tens of thousands of metrics per millisecond, per nanosecond, depending upon the frequency you want. And then on top, you have Chronograph, and Chronograph gives you the complete interface for the InfluxData platform. So you can set up your queries, you can get visibility into InfluxDB, and you can also see those query results within Chronograph as well. A lot of our customers actually use Grafana because then they can plug in those InfluxDB queries right into Grafana, along with some of the other data sources that are already being monitored in Grafana. And if you want to do that, if you're already using Grafana, that is fantastic. You can continue to plug InfluxDB into Grafana as well. And at the bottom, we have Capacitor. Capacitor is a fantastic product which allows you to do real-time things on the streaming data. So let's say you're monitoring memory or CPU temperature. You can say the moment my CPU temperature goes beyond this threshold, send me an alert. Or when my CPU goes beyond this threshold and my memory goes below this threshold, then send me an alert. And it can capture those real-time um, things happening in the real time, those metrics. It can measure those, and it can detect trends and send you alerts in real time. And we support all types of alerting frameworks. Capacitor can work with Ops Genie, PagerDuty, Sensu, and several other industry standards. It can even post a message on your Slack channel as well. And then at the bottom, you see service discovery with Azure, AWS, Kubernetes. We also do anomaly detection, as I highlighted earlier. And then we also plug in with other machine learning algorithms. In fact, if you just Google the InfluxDB and LoudML, we have a very nice blog which goes into details of how InfluxDB can be used with LoudML as well. So you can plug in other machine learning systems where data can go into those algorithms. You can train them, and then you can also use them to see what happens in this case, right? So if you're if one metric is at A, the other metric is at B, what to do? Maybe that what to do comes from a machine learning software, and you can, uh, you know, check in real time on what to do by checking with the machine learning API. And then you can also define your user-defined functions. A lot of developers use these functions as well because they are bringing in some of the capabilities that they have written in the last, a few years, and they want to keep using those user-defined functions. And we provide a very nice mechanism to bring and plug in those user-defined functions onto our tech stack. All right. So what is InfluxData? We talked about metrics and events and how the legacy monitoring is not able to handle the modern needs of DevOps tool chains. But we haven't talked about InfluxData. So InfluxData is a startup. We are singularly focused on building the modern engine for metrics and events for time series data. And time series data is nothing but timestamp data. And there are two types, metrics and events, which I just talked about. But this kind of gives you a flavor of what InfluxData does. We are singularly focused, and we have no other focus other than solving the time series data problem. If you were to ask me about the platform strategy, I would show you this picture. So based on our company goal, which is singularly focused on time series data, we want to be the platform of choice for all metrics and event workloads. Your metrics could come from IoT sensors and devices, and also from infrastructure, which is your servers, your network, and also business metrics, which come from your business SLAs, your things that you have promised your customers and partners, the response times that you have promised, and if you have promised a file going back within 5 minutes of something being delivered, you can measure all those things. And then you can also correlate those metrics with those business events as well, or the user events with the infrastructure metrics, and correlate them to translate them into how business metrics, how you are performing against those business metrics as well. So all these metrics go into the common metrics and events platform, which is our tech stack I just talked about. And essentially, the tech stack is doing monitoring for you, whether it is DevOps tool chains or just pure plain server monitoring, application monitoring, giving you the analytics, the dashboards that you need, and also giving you the tracing and machine learning if you want to plug into any third-party libraries. So a little bit of our history, how we came about building this tech stack and how well we are doing. So let's look into that quickly. So the reason we started this company was that our founder, who was trying to solve some of these monitoring problems for a very large company on East Coast, he found that there is nothing really, not a good solution for storing time series data and processing it. So he started working on solving this problem, And we are a relatively new company. We have existed for the last 4 or 5 years, and our commercial solution has been around for a little less than 2 years. But we have grown very well. You can see this is actually a third party called DB Engines. The DB Engines is showing, they track all the databases, and on the left hand side, you can see that time series databases are the fastest growing database in across all different categories of databases. And on the right hand side, they show how different time series solutions are growing. So you see InfluxDB, which is growing fastest, and you see some other names as well. And some of those names are not purpose built for time series. There are some other databases who have some time series component to it. But we are not a bolt-on. We are pure plain time series oriented platform. And I think that is one of the reasons behind the popularity of InfluxDB as well, and the fact that we are always growing ahead of some of the non-purpose built time series platforms. Another slide which shows our adoption. So open source core, we are fortunate to have a very vibrant, very active user community. Around 15,000 Git stars. We are about 14,500, I guess. And they go up every day. And we have 175,000 databases in use today. And the reason we say that is our database has a phone home feature, which we encourage users to disable if they would like. And most of our users, I would say 50 to 60% disable it. But if you don't disable it, then we get to see who's downloading and using our database. And other than that, we don't get any information out of that. And based on the information we get, we see on a weekly basis, at least this week, around 175,000 databases in use. The actual number could be double or a little bit more than the double as well. On the right-hand side, you see the monthly growth. It is we are growing very well, and the time series needs have expanded in the real in the recent times, and we have seen companies like these who are now looking at or adopting InfluxData's time series platform. So some very big names here who are using our technology, and we will go into a little bit more detail on we will break down some of these use cases for you, and also uh, look at some of the use cases and how they are using InfluxData today. Our company's core focus, the audience is developers and builders. We are not selling to the CEOs. We are not selling to the business line. It is IT focused, very developer and builder focused for application monitoring, server monitoring, DevOps monitoring, microservices monitoring, and a few other things which I will talk about. But our goal is to build an easy to use open source platform, which is not only easy to use, adopt, but also super easy to deploy. So we are trying to solve the DevOps problem by supporting the monitoring aspects and also working very well with the whole idea of DevOps, something that is easier to uh, build, adopt, and deploy. You have seen this picture before, so I wouldn't spend a whole lot of time on it, but I would just like to mention one fact that as these metrics and events go into our platform, there are four things we do. You have seen this picture before, and this is what exactly we want to do. Our goal is to accumulate the events, analyze the events, and act on it. There are other time series solutions out there today which may do one or two of these things, but not the whole stack. So our goal is to give you complete time series capabilities all the way from ingesting those data points, those metrics and events, getting them into the database, and then analyzing these metrics and events, and then finally give you the option to act in real time, to visualize, to notify, to automate, and whether it is your decision makers, system admins, or your IoT devices which need to be notified, we can handle any of those use cases. A little bit more about our stack before we go into our customer base. So open source core, what does that mean? That means that everything here, Telegraph, Chronograph, InfluxDB, and Capacitor, the four things below the open source core line, they are all um, part of our open source core, and you can download them, install them. You can use all four together, two or three together. The reason they are different is that some customers want to use Telegraph and Chronograph, or just Telegraph and InfluxDB, and you can pick and choose what you want. And then on the top, you have Influx Enterprise, which is our enterprise offering for advanced needs for clustering, manageability, security. And if you don't want to install anything, if you're a startup like us and everything you have is in the cloud, then you can just stream those metrics from your DevOps toolchain into our Influx cloud. And that will give you all those metrics and events in the cloud, in our cloud hosted by us. And that is not it's a paid offering. Um, so everything below the line, open source, everything above the line, two things, enterprise and cloud, paid offerings. All right. So the market-leading time series platform built specifically for metrics, events, and other time-based data. This is the crux of what we do. And we have actually trademarked the fastest time to awesome phrase just because that's our goal. Every time we build something, our goal is to make sure that the developers can download it, use it, and put into production. And at the end of all that, they should say, wow, this was easy. If they're not able to experience that time to awesome, then we have failed in our mission. So, and that's the reason I think we talked about the 175,000 developers that use actively today that we know of. And I think this is one of the biggest reasons, because our product is very simple to download and adopt. And also enabling companies to take action while it matters, not after 1 second or 5 second sample rate. We are happy to go down to the sampling level that is required by your DevOps toolchain. And we are fast, scalable, available, and you can deploy Influx solutions on your on-prem environment, your cloud environment, or in our cloud environment as well. So full flexibility into deployment as well. So without further ado, let's move on and see what kind of customers we have. I showed a sample, but that sample slide kind of didn't break out the customers into what exactly they use us for. So we can categorize our products into three areas. At the bottom is infrastructure, application, and business process monitoring. This is where DevOps monitoring will fall as well. We consider DevOps monitoring as part of infrastructure and application monitoring. And you can see some of the big names here. They use us for this particular reason. And then on top, it is IoT monitoring. About 35% of our customer base falls into this segment. So this could also be DevOps monitoring as well, but it usually has a very strong IoT and sensors and device focus. So a lot of these companies are getting that information from their sensors and devices and then feeding it into the application and using us to monitor the whole thing. And then on top is a subset of our customer base which uses our products only for real-time analytics. They want to analyze their infrastructure, network, and how they're performing and what they can do to fix problems and faster troubleshooting kind of thing. All right. With the next slide, we go into some of the customer stories. And SAP is using us for monitoring their SAP Ariba operations. If you're familiar with Ariba, you will know that Ariba is a platform that SAP sells to its customers. And obviously, when you're selling a platform, the platform uptime is extremely important. And also for deploying new versions of the platform, running the whole DevOps tool chain to make sure that the new enhancements are being embedded in the platform. So SAP uses Influx to collect metrics and events for all SAP Ariba operations, and also for providing visualizations and alerting, which is critical to their business. And then we have Tesla, which is InfluxData's customer for their solar city. So you see the solar panels here, and the way they use InfluxData is by monitoring their systems, applications, and sensors across solar and battery installations. And they use us to provide greater visibility and insight into energy usage and maintenance. So this is a great example of an application which is which has a big IoT angle. All right, Siemens, big German conglomerate. They sell wind and gas turbines to large corporations and municipalities. They provide monitoring as a service for these customers. So if you are a large company and a municipality, you have a bunch of turbines, you can also get monitoring as a service application from Siemens. And this will give you usage performance data. And Siemens is using Influx as their key metric store for this SaaS platform. And they allow customers to get this information via the app or via the REST API. And this is all happening in real time via data streaming from each turbine to the cloud service. So data from turbines goes into the cloud, and they can expose that data, those metrics, to you via API. So a lot of times you will have some needs where you want to expose some of these DevOps metrics and events to internally to your other departments. Also DevOps uptime, and if you read the Phoenix project, a lot of times it is better to expose some of these metrics to other departments to show you how you are doing it. And InfluxData is the perfect platform to do that. All right, so one more example before we summarize and conclude the webinar. Wayfair is an e-commerce company. You might be familiar with the name. And they use InfluxData to monitor system metrics and events. And the goal is to marry these with business process events. And this is a very powerful point which a lot of companies miss. There are very few ways to marry your business metrics and business process events with your infrastructure metrics. And once you marry, you can actually not only get visibility into your infrastructure, but also tell business that, hey, our infrastructure was performing slowly because we had more visitors due to the marketing promotion you ran for Black Friday. So you can correlate these angles together and gain what we call it the cross-domain visibility, and also the visibility linking your business SLAs metrics into your system metrics. All right, so one last slide before we open up for questions. This is a summary slide of just to recap what we do as a company. Modern engine for metrics and events. And if you are not familiar with metrics and events prior to today's webinar, I hope you are. Metrics and events are nothing but timestamp data, which we call time series data. And the focus of our company is to give the most advanced, the fastest, the most scalable time series platform for developers, builders, site reliability engineers, system admins, and everybody else who is in some way or shape concerned with application performance, application monitoring, and making sure that the DevOps tool chain and the microservices are delivering what was promised. And the difference is we are purpose built. We are not a hack. We are not a regular database with some bolt-on which does time series. Every component of tech stack is purpose built, delivering fastest time to awesome, and delivering real actions in real time. And that is the reason we have 175,000 plus unique active deployments and over 420 customers, and some of the names and use cases you have seen just now. And with that, we open up for questions.
All right, that was great. Actually, that was pretty cool because if I understand this correctly, you can travel through IT time using the Influx database and a capacitor data processing engine. And unlike Michael J. Fox, you don't even need a DeLorean. So I want to encourage everybody to look at their screen and find that little button that says questions on it. And by all means, we mean this to be interactive, so please ask us some questions. And with that, we're going to jump to our first question. So what is exactly the difference between downloading the InfluxData platform from GitHub versus what you might find on InfluxData.com?
There is only one difference. GitHub is our repository, and you can download the latest and greatest InfluxDB stack from there. But then we get no visibility into who you are. From time to time, we run promotions where we build our developer community. We reach out to developers, and we solicit champions who want to work with us, and we request feedback and also send them stickers and socks occasionally. So if you download it from influxdata.com and you opt in, there we will ask you for first name and email. And if you don't opt in, then we don't know you. If you opt in, then we know you, and you will be part of our community, and you will get the opportunity to work closely with us.
All right, great. Our next question has to do with auto discovery of virtual machines, and one of our attendees wants to know if that's something that the database can track or keep pace with, or how does that kind of impact the way you approach it?
Yeah, absolutely. It depends on which services you're talking about. I would highly encourage you to take a moment and look at the Telegraph documentation. If you just Google InfluxDB Telegraph documentation, you will find it. 182, I believe, is the latest version. And once you go to the Telegraph documentation, it is segmented by around 200 areas, and you can just quickly scroll down to the area that you are interested in and what kind of services that you want to be discovered. And then you can just focus on that and see if it meets your needs or not.
Okay. Our next question, I guess, comes from somebody who's very much an open source proponent, but they would like us to distinguish a little bit with what can they actually get done using only the open source components, and then where is the line between the value added on top of that?
Sure, you can do anything with the open source, but it is restricted to one node only. So you can actually have multiple nodes as well. But if you are trying to run in a high availability mode, then high availability and some of the enterprise level security features are only available in the enterprise version. But practically everything else is available in our open source core tech stack as well. So there are some big names who run open source, and then there are some big names who choose to go for the security, troubleshooting, support, and all that stuff, and they opt for the enterprise version. But there is no other restriction other than high availability and some of the enterprise features which are only available in the enterprise version.
All right, and that naturally brings us to our next question. One of our attendees would like to know, is there any kind of benchmark or pattern that you see when people start using the enterprise version? How many instances, or are there any metrics on that level?
Yeah, so there are a lot of metrics depending upon what size companies we have. We see that a lot of startups and smaller companies, they use our cloud platform, and some of the bigger companies, they like to deploy our solution on their cloud solutions. So we have customers, which range from 10 employee company to 100,000 plus employee companies, and they all act and behave differently, and they all deploy differently as well. So depending upon, we are happy to have a conversation after this webinar, and if you are interested, we can get you in touch with some of the solution experts who can look at your particular situation and come up with some recommendations on how you can segment. And if you want to stick to open source, we actually have a very vibrant open source community, and you can get all sorts of questions answered via that community as well.
Our next question goes to the size of the infrastructure required to run InfluxData in the database. Can you give us some sense of what the number of CPUs, storage, etc., might be required?
So we are written in the Go language. We are very fast, and we have a very small footprint. So think of less than 100 megabytes as footprint. And so if you want to run Influx, I actually run the whole tech stack on my laptop, and it gives me, I can run everything else, including my mail, PowerPoint, and everything else without any issues. So it's very small footprint, and it all depends on what you're trying to do. If you are only measuring one or two things and you only run Telegraph, then it has like zero impact on your CPU. But if you are running it as a large InfluxDB server and you are ingesting millions of events per second, then obviously you will need to have processing and the disk space and everything else to go along with it. And also depends on how much data you want to retain for your monitoring, right? So a few things to consider: which part of tech stack you're running, and what is the capacity you're looking for, how much processing you will do, how much data you will store, and how often you will compact and evict the data. So all these things will play a role. But from, if you just want a developer stack, you want to test it out, you want to see, play around with it a little bit, any computer built in the last 10 years can run tech stack.
Okay. Our next question comes from somebody who apparently is interested in building some sort of value-added service on top of your database. And their question is, what kind of telemetry data do you collect about the database itself? Do you share that information with them? And do people have to opt in for that, or how do they get that data?
So we do not get the telemetry data, from the InfluxDB instance. If you're running InfluxDB and you want to monitor it, you can certainly do that. And if you are one of our cloud customers and you want us to monitor your telemetry data, we can do that as well. But if you are one of our open source community members, the phone home feature just tells us that somebody has this database running. We don't know who it is, and we don't know what the telemetry for that database is. So depend on what you want us to do. If you want to host in our cloud and you want us to monitor the telemetry, we can certainly do that.
Okay. Our next question goes to the issue of tagging, and can you tag resources in the database? And if so, what does that look like?
Yeah, so we are very open to tags, and we have seen developers who like to tag everything and developers who do not. So we work both ways. If you want to tag the metrics, please go ahead. And if you don't want to tag, that's fine as well. I know some systems out there force you to tag. We are not one of those. So we are very flexible because we understand developers have their own preferences, their own way of working. Some like to tag, some don't like to tag, and we are flexible.
Okay. We have a more of a comment. Somebody is interested in the capability of the hundreds of thousands of transactions per second that you can do with the database. Maybe you could just jump into a little bit about why that's required now as we go forward and in these modern architectures a little bit more.
Sure, why not? I'll give you an example. Think of a streaming service. Let's say you're a media company and you sell movies and episodes, and people are binge watching some of those episodes. And suddenly you get a call. Hey, I bought this movie, and in the middle, 15 minutes into the movie, it stopped working, right? So you have no idea, as a customer service person, you have no idea whether the customer is, telling the truth or not. So, but if you were monitoring all your streams at a millisecond level, so any interruption more than 5 millisecond gets reported where a person has, and then you can see that this person is actually telling the truth. They bought this movie, and as they were watching this movie, the stream, the data stream going out to this particular customer was interrupted 50 times, and every interruption was more than 5 seconds, right? So you can get all that type of metrics. The more customer obsessed you are, the more you care about your application and its performance, the more metrics you want to gather about the performance, and you can go to nth level to monitor everything around customer expectation and behavior.
All right, cool. One other question is, there seems to be a little bit of confusion, not much, but what exactly is the difference in capabilities from Influx Cloud versus the enterprise version? Are they one and the same, or are there different capabilities in different platforms?
So in fact, they are exactly the same, no difference. Influx Enterprise is where you buy the license and you host it in your cloud or on-prem, depending upon wherever you want to host it. Some of the big names, they have their own data centers. Some of our bigger customers have their own data centers. I should say some of the biggest customers we have their own data centers. Some of the bigger customers we they have contracts with Amazon and other cloud providers. So they buy the enterprise license, they run it in AWS or wherever. And then finally, we have mid-size and smaller customers. The smaller customers, especially, they are very flexible. They are cloud. Most of them are cloud only. All the startups that use InfluxData, they simply want to be on our cloud. So our cloud offering is where we host it, we run it for you, and you just start using it, putting your data into InfluxDB, but everything else is the same.
One last quick question here. Time series database, do you think that when it comes to monitoring that people have overlooked this whole issue of the when factor, and is that becoming more important?
Absolutely. So every piece of technology advancement we see with the autonomous vehicles, self-driving cars, robots, everything we see for the future has a big use case from time series data. Think of a car which is driving and the sensors are emitting information. A lot of that information is useless, but you need to capture a lot of that information and downsample it and store it and also make decisions in the real time whether the car is turning right or left. So this timestamp data, the time series data, it's truly been overlooked in the past just because you couldn't do much with it. You knew that your server was slow, but you couldn't buy a box and install the app server on the fly. Now you can, right? So we are seeing more autonomous systems. We are seeing these instrumentation needs that are increasing the use for time series, and that's why one of the slides, highlighted the time series is emerging as the fourth category of data platforms after the big data platforms.
All right, great. Hey, Nadeep, I want to thank you for sharing your knowledge with us today. That was absolutely amazing.
You're very welcome. Happy to be here.
All right. And I want to thank you all for spending some time with us and watching this webinar with us live. You can also download it by visiting devops.com, where you'll find all kinds of interesting webinars. And with that, I wish you all a great day, evening, morning, wherever you happen to be, and best of luck in your next IT adventure.